should play that sound more often. Hi, everybody. How are we doing today? Good. In my mind, they all responded. There's the key for the homework, so go ahead and pause if you need to and go over anything. But yeah, let's, any questions on anything else on the homework for the in-class students? No. Okay, let's get to the notes then for today. Section 7.4, properties of logarithms. Now, just to remind you guys where we're headed, we have done a lot this week already. This is section 7.1, 7.2, 7.3, 7.4. Right off the bat, 1, 2, 3, 4, one day each lesson. So tomorrow we're going to review section 7.1 to 7.4. I've got a review assignment for us to do. It's out of the book. And then on Tuesday of next week, remember no school on Monday. On Tuesday next week, we're going to review. And then on Wednesday of next week, we're going to have a quiz. And it's half no calculator at all, half calculator. Okay. A lot of what we will do today I can give you on the non-calculator portion. Okay. What we're going to do today is think about how do we operate, how do we work with logarithms, okay? How do we manipulate logarithms. Okay? This is all the properties of logarithms. Now, because the logarithm is an exponent, right? We learned that by definition. Yesterday we learned that a logarithm is an exponent. I had us underline the word is, right? Because logarithms are exponents, you can derive the properties of logarithms from the properties of exponents. We all remember our exponent properties, right? I multiply with like bases, that means I add the exponents. I divide with like bases, that means I subtract the exponents. I take a power to a power, that means I multiply the exponents. All those things, okay? Those are going to be crucial today when finding the properties of logarithms. Let's first start off by thinking about the multiplication property of exponents, right? This is something that you learned back in Algebra 1. I just taught it to my Algebra 1 students. Chapter 7, we just had our test over it. B to the m times b to the n is b to the m plus n. Now, so that means multiplication of the bases requires addition in the exponents. So, if a logarithm is an exponent, what I can say is if I have addition of the logarithms, that actually means multiplication of the pieces inside. Here's what I mean. Okay. This is the piece over here that that's not a pen. This is the piece over here that I would circle, star. All right, so what was I saying? Because exponents requires, if I've got multiplication of the base, that requires addition within the exponent. Same type of thing here. Look what I've got. I've got multiplication of the pieces inside the log, right? I would almost even go so far as to say, write it like this: log base b of the quantity m times n, because I want to reinforce that it's acting on the product, right? It's acting on the product. You're taking the logarithm of the product. So the log base b of m times n is actually the log base b of m plus the log base b of n. Now, did the base ever change when working with exponents? I had to have like bases. Like I couldn't even combine like an x squared and a y to the third, right? I can't combine those things. I can't multiply those things together, right? I can't make like x y to the fifth or anything like that. You can't do that. It's got to have like bases. The same thing is true for logarithms, and you're going to see that throughout. The base must be the same. You must have the same log base for these to be able to for this to be able to work. And this is a biconditional statement. This works both forward and backward. I could say log base b of m plus log base b of n is equal to log base b of m times n. So however you need to manipulate it, however you need to work with it, you can make this go forward and backward. Oh, I'm going to turn off my sound. Okay. There we go. All right, so let's practice with that. Nothing else on that side, right? Log base 6 of 4 plus log base 6 of 9. Like I could give this to you on a no calculator pretty easily. Log base 6 of 4 plus log base 6 of 9. Now, can you compute log base 6 of 4? Like mentally, think about it. Can you compute log base 6 of 4? I'd be asking you to say 6 to the what power is 4? Well, that doesn't make sense, does it? 6 to the what power is 4? That's some decimal. It doesn't come out as a nice thing. Same thing as log base 6 of 9. 6 to the what power is 9? That doesn't make sense. But here's what we could do. Addition of the logs means multiplication within the logs. Right? And again, yeah, you could just go straight to 36. Log base 6 of 36. Ah, I can do that. What is log base 6 of 36? 2. 6 to the second power is 36. Okay, so the directions are going to say express as a single logarithm. Right? Express as a single logarithm and then simplify. So this is express as a single logarithm and this is your simplify. Okay?
Why is it multiplication and not like 4 plus 9?
Because that's not how it works.
Oh yeah.
Right. Addition of the logs means multiplication. Just like multiplication of the bases meant addition within the logs, or within the exponents. Because again, exponents are logs. All right, let's take this one here. Now this one I would not give you on a no calculator. I'm not going to make it. Why do I say that? What are you going to have to do here? Yeah, multiply 625 by 25. Yeah, I'm not going to do that to you. I have to take log base 5 of the product 625 times 25, which is 15,625. Now, how do I solve this log? Well, I got to think about what power of 5 gets me to 15,625. So let's try 5 to the 5th. I don't know. Okay, I need to go higher. 5 to the 6th. There it is. 5 to the 6th power. So this is equivalent to 6. So again, it asked us to express as a single logarithm, basically to reduce it, and then to solve it. You're going to see on your quiz that there are 2 answer blanks, one to reduce, one to solve. And this last one here. Now this looks a little messy. I'm not really sure what to do with this. We've got log base 1/3. What's going on here? But let's see if I can use the addition to reduce it down a little bit. All right, so this would be log base 1/3 of what? What's 27 times 1/9? 3. Right, 27 divided by 9 is 3. Well, what is that equal to? Well, again, if we need to think about it, let's transfer it into from logarithmic into exponential form. This would be like saying 1/3 to the what power is 3. Well, what takes it from the bottom to the top? -1 exponent. So this is -1. Log base 1/3 of 3 is our simplify. Right as a single log, and then -1 evaluate. All right, so that's the addition property, the multiplication property. We also know this property of exponents. When you're dividing with exponents and their like bases, again, we've got to have like bases, we would subtract in the exponent. So think about what happened with our logarithms. I had multiplication on the inside of the logs, which meant addition of the logs. So if I've got division inside the logs, it's going to be subtraction of the logs. Because remember, the logs are exponents. And here is my property over here. Log base b of m divided by n is equal to log base b of m minus log base b of n. Division within the log is equivalent to subtraction of the logs. Okay? This is such a silly example. Like, look at that example on the inside. Does that reduce anything? Like, how silly is that? Why? I don't understand that. Why do they do it? I mean, I know they're just algebraically showing, but like, really going to try to evaluate log base 5 of 16? Like, why are you splitting that up like that? That's weird. All right, let's do an example. Oh yeah, got to have the same base. Talked about that already. Cool. All right, take a look here. Log base 5 of 100 minus log base 5 of 4. I could definitely do this. Because think, first off, can I evaluate this separately? Can I take log base 5 of 100? 5 to the what power is 100? Yeah, that does not compute. So we have to, and same thing as log base 5 of 4. So we have to reduce it down with our property. So subtraction of the logs means division within the log. So what is 100 divided by 4? 25, thank you. I'll write it like this for you. 25. Oh, sorry. So that would be log base 5 of 4. Whoa, wow, it's early. Log base 5 of 25, which is what? What is log base 5 of 25? 2. 5 to the second power is 25. So log base 5 of 25 is 2. So this is expressed as a single logarithm, and then evaluate, simplify, which is 2. Okay, let's take a look at the next one. Now this one I could have simplified, or I could have evaluated before I simplified, because, can I take the log base 7 of 49? Yeah. Can I take the log base 7 of 7? Yeah. But let's see what happens when I use the subtraction rule. Remember, that is log base 7 of 49 over 7. You do not need to write that step. I'm just showing it to show the property. And that is log base 7 of 7. Log base 7 of 7 is what? 1. That's one of our unique properties from yesterday, right? Log base b of b is 1. Log base 10 of 10 is 1. Log base 7 of 7 is 1. Because the exponent is always going to say 1. How would that have worked if I didn't ask you to simplify first? We could have said 7 to the what power is 49, 2. 7 to the 7 power is 1. Subtract them, 1. We get our same answer. Okay, so because we can multiply logarithms, you can also take powers of logarithms. Okay. Think about our property of our power to a power property, right? Think about our power to a power property. A to the m, it's not written in here, but a to the m to the n is equal to a to the m, a to the m times n, right? Product up there. Does that apply here? I'm not thinking about the same one. I'm thinking about a different one, aren't I? No, I don't know if that applies here. The power to power rule? I think it may, but I don't know. At any rate, this is the power property of logarithms. Basically, what's going to happen here is we're going to take this power and we're going to bring it around front and multiply. Okay? We're going to take that power and we're going to bring it around front and multiply. Oh, I know what I'm thinking about here. Oh, that was silly. Never mind. I'm thinking about you can kind of do this repeated multiplication rule. Okay, you can do this repeated multiplication rule. Because think about it this way. Yeah, they're showing you here with log base 10 of 10 to the third. Think about 10 to the third power. Isn't 10 to the third power 10 times 10 times 10? So we can repeatedly multiply it as 10 times 10 times 10. Well, we know from our product property is that product within the log is addition of the logs. So we could say this is log base 10 of 10 plus log base 10 of 10 plus log base 10 of 10, which essentially is 3 of those things. So it's 3 log base 10 of 10, right? So what can you do here? You can take a power and you can bring it out front and you can multiply. That is actually a very, very useful statement that we will use a lot in solving other types of equations as well. If we can make things logarithms, if we can turn things into logarithms, we can use these properties that are unique to logarithms to maybe help us solve some equations. All right, let's try that. Try these couple. Log base 2 of 32 to the 6th power. Now, you might be thinking, well, okay, take 32 to the 6th power? Yikes, right? I can't evaluate that without a calculator. But I can if I use the power rule. Okay, what does that mean? That means I can take this 6 and bring it around front and multiply it. So 6 times log base 2 of 32. Now, how does that help us? Can I evaluate log base 2 of 32? Yeah, any log base 2 is an easy number. I've got 2 to the first power is 2, 2 to the second power is 4, 2 to the third power is 8, 16, 32. 2 to the 5th power is 32. So I know this is really like 6 times 5, which is 30. I know, crazy. So you can use this rule to bring it around front and then evaluate the log. See, all I did here with this 5 was just evaluate log base 2 of 32. I had to figure out what power to raise 2 to get to 32, to the 5th power. Yes, it is. All right, take a look at B here. So I can bring this 4 around front and multiply it. And this would be 4 times the log of 10. Oh, now that's easy to compute. What is log base 10 of 10? 1. So this is just 4 times 1. Or just 4. The directions say express as a product, then simplify. So if I asked you to do that, I would say, okay, that's the express as a product. That's the express as a product, and then simplify it to 4. Beyond this section, like beyond section 7.1 and 7.4 quiz, I'm not going to be asking you to write it simplified like that. I'm just trying to get you to work with the properties. Is there another one down there? Yeah, there's another one. Log base 5 of 25 raised to the 2nd power. See, I don't want to take 25 to the 2nd power. I don't want to evaluate what 25 to the 2nd power is. So what's easier to do is bring this 2 around front and multiply it. 2 times the log base 5 of 25, because that's very easy to do. What is log base 5 of 25? 2. So this is essentially 2 times 2, or 4. Could I evaluate that differently? Yeah, I could have taken 25 to the 2nd power. 25 to the 2nd power is log base 5 of 625. And then I would have said, okay, what's 5 to the what power is 625? 4. 5 to the 4th power would have gotten us to 625. See, I could do this long way, but if I'm without a calculator, no, that's not possible. Exponential and logarithmic operations undo each other since they are inverses. So these are very, very unique rules, ones that don't happen very often, ones that are very special case. If you have an exponent within a logarithm, kind of like what we were working with just then, but you've got to have the same log base as exponent base. If you have the same log base as exponent base and you've got a power there, it actually will undo each other and cancel each other out. So I think we saw it up here where it was log base 10 of 10, right? This is the property that I'm demonstrating. Look, I've got the same log base as of number, log base 10 of 10. Those will cancel each other out, leaving just our exponent left over. Log base b of b is equal to x. Log base b of b to the x power is equal to x. Log base 7 of 7 to the 5th power is 5. Log base 2 of 2 to the 8th power, just 8. Okay. Also, if you've got a log within an exponent, right? Because again, they will undo each other. If you've got a log within an exponent, and as long as those log base and those exponent bases are the same, they will undo each other, and then it'll just leave you with the of number within the log. So for example here, this 10 to the log base 10 of 2, 10 to the log base 10 of 2, those will cancel each other out, leaving just a 2. Take a look here. So I've got log base 3 of 3 to the 11th power. What would that be? 11. Yeah. These are cases where this does not occur very often. But when it does, man, does it help us. It's like, oh, man, that's nice. That simplifies down. This second one may not look like it's going to. But guess what? Can I make the of number as a power of 3? Like log base 3 of 3 to the what power is 81? 3 to the 4th is 81. And now look, log base 3 of 3. So that ends up just being 4. That is right. I better check myself. I've already made several mistakes today. Okay, good. Now, couldn't we just have evaluated that log? Yeah. Yeah. you're going to find that with logarithms, there are multiple ways to solve these problems. Yeah, your brain may work differently than other people's brain, and some people are like, oh, I like that method better. I like this method better. I like to add better, whatever. Totally fine. However your brain works. So these are special cases where I've got the same log base as exponent base. Take here, exponent of 5, exponent base of 5, log base of 5. Those are the same number, so I just get 10. 5 to the log base 5 of 10 is just 10. If you've ever got the same exponent base as logarithm base, those will cancel each other out. So 2 to the log base 2 of 8x, just 8x. Again, that's a very unique case. A very unique case. Now, why is that happening? Let me show you here. 2 to the log base 2 of 8x. Because this seems like an odd rule. Let me ask you this. If I were to say, well, what does that equal? Look what I'm going to do. I'm going to transfer. This is technically an exponential form. I've got a base, an exponent, and equal to something. And I don't know what that something is. So if this is an exponential, watch what I'm going to do. I'm going to turn it into logarithmic. Log base 2 of something is equal to whatever's in the exponent. Look at my two sides of my equation. What should fill in that blank? Is x, right? Okay, now last property. Now, this one will not really apply to most of you. This one will not really apply to most of you because, spoiler alert, your calculators do more than just log base 10. I said yesterday that mainly our calculators do, I don't know if I talked about the other one, but your calculators do log base 10, common log, but your calculators will also do this ln, that's natural log, log base e, which we'll look at in section 7.6, log base e, that's log, common log, and then ln, log base e, natural log. My calculator will only ever do those two log bases. My calculator doesn't have the option of changing the base. However, your new fancy-dancy calculators will change the base. Let me show you something here. Everybody go into math, into your calculator. Because some of you may be like my calculators. Like, if you got the really thin ones, those ones are the newer ones. That may have it still. Click on math, and then scroll down. Do you guys have a function called log base? Hit log base, and it will allow you to change the base. Okay? Do you have it? Oh, no. See, you're going to need to learn what I got here. That's okay.
That's so sad.
Does anybody else not have log base? Just join. So you guys, you can evaluate any log now. Like they've updated the calculators. You can now evaluate any log. See, I don't have that down here. If I scroll down, there is no log base function. I think that's it. Yeah, it jumps back to the top. So here, now everybody watch, just in case you're doing something and you have a red calculator or something like that, and you can't possibly use your log base function. What we actually have is what's called the change of base formula. This is really cool. This is the change of base formula. It says that you can change. Here he's talking. It was just like recorded everything he said. You can change the base of any logarithm to whatever you want. It seems weird, but you can. You can change the base of any logarithm to whatever base you want. You can change it to log base 3, like base 4, base 5, or base 10, because your calculator will do base 10. Right? You can change any logarithm to log base 10. What you have to do, take a look at this right here. If you've got log base b of x, whatever it is, you can create a new log base to say log base a of x. So your of number goes on top. Your base goes on bottom. You can say log base a of x divided by log base a of b. So that means I can evaluate anything, log base 3 of 5. Now think about this. 3 to the what power is 5? I don't know. Some decimal. So what I can do here is change the base and say log of 5 divided by log of 3. What did I change the base into? The base 10. Look here. Log of 5 divided by log of 3. Log base 3 of 5 is equal to 1.465. 1.465. Okay? And those of you with your log base function, your spiffy new calculators, you can actually do that in your calculator. You can take log base 3 of 5. But we're going to practice a little bit of the change of base formula real quick. So here, log base 32 of 8. Log base 32 of 8. Well, that would be like saying log of 8 divided by log of 32. So I'm going to go in my calculator and say log of 8 divided by log of 32. 0.6. 0.6. Now this I must give you on a calculator portion. You cannot do this without a calculator. Okay? Take a look here. Log base 9 of 27. I could make that log of 27 divided by log of 9. Log of 27 divided by log of 9. This one is actually unique. Everybody take a look up here. Eyes up here real quick. Watch what I can do. I can actually make this, if I didn't have a calculator, I could actually make this solvable. Watch how I changed both bases to 3. What is log base 3 of 27? 3 to the what power is 27? 3. 3 to the what power is 9? Which is 1.5. So that's how the change of base formula can be useful. For our purposes here, we're just thinking about it more of like just calculating it. Like what's the decimal value? Like here, I can say log base 10 of 10 over log base 10 of 1/2. All right, let's see what that is. Log of 10. See, I know that's 1. I just got to figure out what log of 1/2 is. Log base 10 of 10 divided by log base 10 of 1/2. Negative 3.32. And that's my answer. Okay. All right. Let me get you some time to work on your homework. 11 minutes. 11. I'm so generous. So long, everybody at home.